An optician holds a 4 times magnifying glass over a small angle 1.5 degrees. The glass sits over it. The angle is visible inside the lens. The question is immediate. What angle do you see through the glass? You have 5 seconds. Pause and try it. The lens magnifies 4 times. Surely the angle is 4 times larger. 6 degrees. Wrong. The angle through the glass is still exactly 1.5 degrees, unchanged. And the reason why is one of the most elegant facts in optics. Start with something the lens genuinely does change. A ruler. 1 centimeter under a 4 times lens appears as 4 centimeters. That magnification is real. It is why we use lenses. Now consider an angle. 2 rays diverging from a single point, the eye. The object at distance d, height h. The angle it subtends at the eye is defined by the ratio h over d. The lens creates a virtual image. 4 times farther away, 4 times taller. Distance multiplied by 4. Apparent height multiplied by 4. The angle at the eye, 4 times the height, divided by 4 times the distance. The 4's cancel. The angle is unchanged. The arc at the eye is identical. The angle is identical. There is a principle hiding inside this. The radian measure of an angle has a definition. Draw any angle. Draw an arc connecting the 2 rays centered at the vertex. Call the arc length L and the radius r. The angle theta equals L divided by r. That is not an approximation. That is the definition. Angle is a ratio, not a length. This single fact explains everything that follows. After the lens, the apparent arc grows to 4L. The lens made the object appear larger. The arc it subtends has grown. The apparent radius, the apparent distance to the object, has also grown to 4r. The object appears 4 times farther away. Theta after the lens, 4L divided by 4r. The 4's cancel. Theta equals L over r. The ratio is invariant. This is not a coincidence. This is what it means for a quantity to be defined as a ratio. Arc for 1.5 degrees at 1000 millimeters is 26.2 millimeters. After the lens, 4 times 26.2 divided by 4 times 1000 times 180 over pi. Answer, 1.5 degrees. Return to the question. 1.5 degrees through a 4 times lens, still 1.5 degrees. The common assumption, if arc scales by 4, angle scales by 4. That treats angle as a length. Angle is not a length, it is a ratio. 4L over 4R. The factors cancel. The ratio, the angle, is preserved, every time, without exception. The principle in one sentence. A lens scales arc length, apparent size, and resolved detail. It does not scale angle. What a lens scales? Arc length, apparent size, resolved detail. What a lens preserves? Angle. Quantities scale. Ratios are preserved, and now, 2 more contexts where the same invariance appears. An architect draws a room corner at 37 degrees. The blueprint is at 1 to 50 scale. Every measurement is 50 times smaller. Both arms of the corner shrink by 50. The arm going right divided by 50. The arm going up at 37 degrees, also divided by 50. The wrong instinct. Divide 37 degrees by 50. That gives 0.74 degrees. Wrong. The angle is a ratio. There is no unit length to shrink. You cannot divide a ratio by a scale factor. The arc becomes L over 50. The radius becomes R over 50. The 50s cancel. Theta is L over R, unchanged. 37 degrees on the blueprint. Same as the real room. Scale drawings preserve angles. That is why architects read angles directly from blueprints. The ratio is what it is. Scale does not touch it. Two roads meet at a 52-degree junction. A cartographer produces a map at 1 to 25,000. Every road is 25,000 times shorter. Both roads shrink by the same factor. The scale is identical in every direction. Wrong. 52 degrees divided by 25,000 is 0.002 degrees. Invisible. Same reason as before. The arc and the radius both shrink by 25,000. The ratio, the angle, is preserved. 52 degrees on the map. Both junctions show 52 degrees. The arcs are identical. Pilots navigate using angles on aeronautical charts. Surveyors stake out boundaries. Architects specify roof pitches. In every case, they trust that the angle on the drawing equals the angle in the real world. Because it is a mathematical fact. Angle is a ratio. Scale the measurement and its reference equally. The ratio does not move. A ratio is preserved when numerator and denominator scale equally. The magnifying glass, the architect's blueprint, the cartographer's map. The context changes. Optics, geometry, cartography, but the invariance is the same every time. Scale the measurement, scale the reference, the angle never moves. If you enjoyed unraveling this mathematical mystery with us, hit the like button and subscribe for more deep dives into math and science. Let us know in the comments what other puzzles we should explore next. Thanks for watching.